is a lesson on factoring, putting it all together. Okay. So let's look right here. I'm gonna kind of go through these a little bit faster than usual. Okay. Because it's just factoring. Okay, but I want to show you as complicated as it should get. I'm gonna go minus 2x to the power of 4 is the GCF. 81 x to the power of 4 minus 1. Okay, now that's just GCF. Ain't nothing crazy about that at all. Okay, now watch this. I'm gonna perfect square this. Okay, let me actually write it like this. This is a perfect square of 9x squared. That's a perfect square of 1. And it's a plus minus scenario. Okay, 9x squared minus 1, 9x squared plus 1. And then you can perfect square this yet again. This is 3x, that's 1. And we get negative 2x to the power of 4, 3x minus 1, 3x plus 1, and 9x squared plus 1. Okay? And that's it. Okay? And your zeros, your x-intercepts, I should say, okay, is going to be 0, 1/3, negative 1/3. And if you solve for this, you're going to get imaginary. You're going to get basically square root plus minus of negative 1/9, which makes this imaginary. Okay? Yes. Ah, dude, who is this? Devin? Oh, great question, Devin. Thank you. So Devin asks, how come 9x squared plus 1 is not a perfect square? That's a great question. So upon first sight, it is. Okay? So I'm going to do a little side hustle for 9x squared plus 1. Upon first sight, it is. Okay, of 3x and then of 1. Okay? However, okay, you can play around with the signs till the day you die. Meaning you can do a double plus, you can do a double minus, a double plus, or 1 each. You will never get to 9x squared plus 1. Okay, when you do a double-double distribution. So Devin, why don't you tell me to try a certain scenario? What do you suspect it might be? A double plus, double minus, or 1 each? Do a double plus. Okay. Okay, Devin wants me to do a double plus. All right, so I'm going to do double plus. Boom, boom, becomes 9x squared plus 3x. Boom, boom, becomes a plus 3x plus 1. Devin, you see what happens there? You see what I'm saying? And if you do and so that becomes a plus 6x. Now, if you do a 3x minus 1, 3x minus 1, you'll get a minus 6x. If you do 1 each, a plus and a minus scenario, well, then you'll get a 9x squared minus 1 after double distributing. So yes, yes, Devin, that's a great question. Anytime you have a perfect square, but it's a plus in the middle, it ain't going to work. So let me say that one more time. Anytime you have a perfect square with 2 terms, this is a perfect square with 2 terms, 9x squared and 1. That's 2 terms. Both are perfect squares. With a plus in the middle, perfect squares will not work. That's a bait. Okay, they're trying to lure you into that. Okay, that's a very common mistake, and I'm very glad. I'm really glad that Devin asked that question. Okay, Devin, we good on that now? No problem. All right, now let's look at example 2. Okay, let's look at example 2. I'm gonna again once again, take out a GCF, okay, of -4. All right. This is going to be a U substitution example. -4x cubed. All right. And I'm going to get 12x to the power of 4 plus x to the power of 2 minus 6. Okay. And I'm going to do a U substitution here. Okay, just like we did yesterday. I'm going to get 3u. Okay. Here, let me show all the steps. Okay, because U substitution is technically still kind of new. 12x squared. 12. Come on, computer. X squared squared plus x squared minus 6. Okay. And I'm going to let U. Okay. Let U equals to x squared. 12u squared plus u minus 6. I get 4u, 3u, and I get plus 3 minus 2. Okay, and I get u equals to -3/4 and 2/3. U equals to square root plus or minus square root, not u equals to, x squared. Okay, x, I should say, equals to -3/4 and plus or minus root 2/3, and this becomes imaginary. Okay, now don't forget, I gotta also bring this down. Okay, I gotta also bring this down here. Okay, and x also equals to 0. Okay, by way of that -4x cubed. Any questions on that, folks? Okay. Any questions? We're just solving for x-intercepts. Okay. Any questions? All right. I should also write right here just to be consistent, which means I'm going to let u equal to x squared, and therefore, after this step, I'm going to get x squared equals to -3/4 and 2/3. Okay. I should not, when I write x squared, I should not write it this way. That's not good mathematical handwriting, but just because we're running out of space, I'm going to write it that way. It's pretty intuitive. Okay. Now, let's go ahead and do example 3. Okay. Let me show you guys example 3. Now, again, let's do a GCF here. I'm going to do a GCF of 3x squared. Okay. 3x squared. Oh, geez, man. It's too early in the morning for me to do this in my head. What is this? 36? Yes. 36x cubed plus 27x squared minus 16x plus, nope, minus 12. Okay. Now this is going to be factored by grouping. Okay, I'm going to go 9x squared. I'm going to GCF the first two terms inside the parentheses. I get 4x plus 3. I'm going to GCF a minus -4. I'm going to get a 4x plus 3. Okay, so long story short, this became that, and this became that through a double GCF. Okay, we just did that yesterday. Now, this becomes 9x squared minus 4 and 4x plus 3 And don't forget to bring down this 3x squared. Okay, I'll actually bring that down at the very end. Now check this out. You can do another perfect square, dude, right here. Okay, you can do another perfect square. And this is a perfect square of 3x. This is a perfect square of 2. Okay, and I get 3x plus 2, 3x minus 2, 4x plus 3. Okay, and again, I'm going to bring this down. And I'm going to get 3x squared. And your answer, okay, your x-intercepts is going to be 0, 0, negative 2/3, 2/3, negative 3/4. Okay? Any questions on those, folks? Okay? I'm showing you these because I want to give you, like I said, this is as gnarly as it's going to get. Okay? This is basically a double perfect square on the top left. Okay? For example, 2, this is basically a GCF then U substitution. This is factor by grouping and then perfect square. Okay, so let me go ahead and write those methods down. I'm going to type it up for you right here real quick. Okay, boom, 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 boom. GCF, perfect square, perfect square. GCF, I'm going to call this U sub. This is GCF, factor by grouping, and perfect square. Okay? Any questions, folks?